given sample. Identify the defects using magnifying glass. Prepare inspection report with proper details. Let us now have a look at the tools required to test weldments for visual examination. Cleaning material: wire wool. Steel wire brush. Welding positioner. Magnifying glass. Welding gauges. Let us now prepare the setup for doing the visual inspection of weld joints. Set of samples will be provided for visual inspection. Keep the sample on a table. Always ensure good lighting is available during inspection. Check the given sample one by one before starting the inspection. Ensure the weld joints are clean of debris such as dust and slag. This will give an attractive appearance to the weld. Use a steel wire brush to clean the sample. Place the sample under a magnifying glass after cleaning the weld bead. Let us now look at the visual inspection process of weld joints. Task 1. Visual inspection of corner joint. Keep the observation register to record the details. Study the weld joint and identify the defect. Inspect the bead under proper lighting. Study the weld joint and identify the defect. Inspect the bead under proper lighting. Use a magnifying glass 2 to 2.5D to ensure straight and uniform welding. Visually observe deviations in the welded sample. Check for slag inclusion or discontinuity on the weld bead. Record the observations in the register with details. After recording the details, proceed to check. Task 2. Keep the observation register ready to record the details. Study the weld joint and identify the defect. Inspect the bead under proper lighting. Use a magnifying glass 2 to 2.5D to ensure straight and uniform welding. Visually observe deviations in a welded sample. Check for porosity along the length of the bead. Check for spatters along the bead of weld. Record the observations in the register with details. After recording the details, proceed to check. Task 3. Visual inspection of single V-butt joint. Keep the observation register ready to record the details. Study the weld joint and identify the defect. Inspect the bead under proper lighting. Use a magnifying glass 2 to 2.5D for any deviation from straight and uniform welding. Observe the bead for defects like non-uniformity and pinholes. Record the observations in the register with details. Let us look at the important guidelines for visual inspection now. Keep the observation register ready. Use the correct magnifying glass for visual inspection. Ensure proper lighting facilities are available for visual inspection. Always ensure cleaned weld bead is inspected for defects.
Recap. Let us do a quick recap of what you have learned from this topic. Perform visual inspection of weld joints. Observe the given sample. Identify the defects using magnifying glasses. Prepare inspection report with proper details. Thank you, students. Let us meet in the next session. Hello, welcome students. In this topic, you are going to learn how to perform inspection on weldments using weld gauges.
At the end of this topic, you will be able to use a weld gauge to inspect welds. Use a weld gauge to check the weld profiles such as leg length, concave, convex, throat thickness, and record the observations in the given format. Let us now look at the types of weld gauges used for weld inspection. Welding Inspection Ruler, Welding Gauge 1. Universal Welding Gauge, Welding Gauge 2. Welding Gauge, Welding Gauge 3. Digital Welding Gauge, Welding Gauge 3. High-Low Welding Gauge, Welding Gauge 4. Economy Single-Purpose High-Low Welding Gauge. Welding Gauge, Welding Gauge 5. Automatic Weld Size Gauge, AWS, Welding Gauge 7. Bridge Cam Gauge. Adjustable Fillet Weld Gauge, Welding Gauge 8. Pipe Pit Gauge, Welding Gauge 10. Skew T-Fillet Weld Gauge, Welding Gauge 12. Visual Weld Acceptance Criteria, VWAC Single Weld Gauge. Pocket Bridge Cam Gauge. Let us now look at the preparations for inspection of welds by using weld gauges. Samples will be provided for inspection by weld gauges. Keep the sample at the place provided. Proper standing is essential for weld gauge inspection. Observe the bead of the given sample of weld joint. Ascertain what kind of weld checking is to be carried out. The weld gauge should be chosen based on the bead profile. Check the sample before starting the weld inspection. Weld beads must be clean to accurately measure the weld gauge. If the weld bead is not clean, use a steel wire brush for cleaning. Place a sample for weld measurement after cleaning the weld bead. Start the process by selecting the weld bead profile by weld gauge. Now let us see the process for conducting inspection of welds by using weld gauges. Task 1. Inspection of welds by using weld gauges. Study the given weld sample for inspection by using a weld gauge. Clean the weld surface using a wire brush to keep it free from dust, dirt and slag. Select the required size of weld gauge and place it against the weldment. Slide the gauge so that the top end touches the vertical plate. The gauge should touch the top edge of the weld to ensure the correct size. Welds with the space between the gauge and toe are undersized. If the toe of the weld is larger, the gauge has more space to accommodate it, as shown. The vertical line on the gauge shows that the bottom toe is larger than the required size. If the weld size 12 mm should be checked for the correct throat thickness. This is done by checking for concave or convex faces on weld beads. The correct face of the weld coincides with the gauge as it is shown. The weld must have the correct throat thickness or size to be acceptable. If it is convex but less than the required leg size, not acceptable weld shows that there is a clearance between the weld toe and gauge measuring face. Task 2. To measure the leg size of fillet weld using AWS standard fillet gauge. Place the gauge against the toe of the weld. Slide the pointer to rest over the bottom plate of the job. The leg size of the fillet is observed on the graduated scale of gauge. This is the leg size of the fillet weld. Task 3. To measure the acceptable convexity of the fillet weld. Place the gauge against the vertical plate of fillet welding. Ensure the 45-degree sides are in contact with both the vertical and bottom plate of the fillet weld joint. Slide the pointer to rest over the weld face joint. Observe the measurement on the graduated scale in coincidence with the slide mark. Record the measurement to find out the acceptable size of weld reinforcement. Task 4. To measure the acceptable concavity of the fillet weld. Place the gauge against the vertical plate of the fillet weld joint. Ensure the 45-degree sides are in contact with the vertical and horizontal plates of the fillet weld joint. Slide the pointer to rest over the concave weld face. Observe the measurement on graduations and the coincidence with slide marks. Record the measurement to find out the acceptable size of weld reinforcement. Task 5. To measure reinforcement on a butt welded joint. Place the gauge on the butt joint so that the pointer may be seated over the weld seam. Observe the measurement and record accordingly at concave or convex portion of the weld by placing it in position. We are going to use the weld gauges to look at the essential points that need to be monitored for inspection of welds. Keep the weld joint ready before doing the weld gauge test. Ensure the weld bead is free from dirt, dust and slag. Keep all the weld gauges on the table while conducting the test. Keep ready with weld gauge specification notes for all joints.
Recap. Let us do a quick recap of what you have learned from this topic. The types of weld gauges. How to use weld gauges for inspection of welds. To check the concave and convex of fillet weld profile. To check the leg length and throat thickness. Thank you, students. Let us meet in the next session.
Welcome, students. In this topic, we will learn about square butt joint on 2 mm thick MS sheets in horizontal position using the OAW process.
At the end of this topic, you will be able to select appropriate filler rod for tack welding and welding process. Prepare and set plates for square butt joint in horizontal position. Tack weld. Inspect the weldments for defects. Now let us look at the tools required for a square butt joint on 2 mm thick MS sheet in horizontal position using OAW process. Steel rule, scriber, nozzle, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, copper-coated mild steel filler rod, oxygen and acetylene cylinder and welding torch. Personal protective equipment. Now, let us look at the pre-welding preparations for square butt joint on 2 mm thick MS sheet in horizontal position using OAW process. Follow necessary safety precautions. Cut two 2 mm thick MS sheets, 150 mm length by 50 mm width. File or grind the edges to square and ensure thorough cleaning of the joining edges. Set the weld pieces and square butt joint with a root gap. Select the nozzle number 5. And CCMS filler rod dia 1.6 mm. Adjust the pressure of oxygen between 0.5 and 1.41 kg per square centimeter and acetylene at 0.8 to 0.15 kg per square centimeter. We have seen the pre-welding preparations. Now, let us look at the welding process of square butt joint on 2 mm thick MS sheet in horizontal position using OAW process. Prepare and weld square butt joint. set the weld pieces on the welding table. Tack weld. Position the crossbar of the positioner to the eye level. Adjust the pressure of oxygen between 0.5 and 1.41 kg per square centimeter and acetylene at 0.8 to 0.15 kg per square centimeter. Set a soft neutral flame. Hold the blowpipe at 60 degrees to 70 degrees and the filler rod at 30 degrees to 40 degrees to the line of weld. Deposit the bead from the right end of the joint by giving a circular motion to the blowpipe and proceed towards the left end. Ensure both edges melt equally and up to the root of the joint. Check the weldment for the correct profile with complete penetration. Now, we will look at the important points to follow for a square butt joint on 2 mm thick MS sheet in flat position using OAW process. Wear safety apparels and gas welding goggles. Checking the uniformity of width and height of the weld bead in size. Inspect the quality of weld by checking the finishing weld. Blow holes. Lack of fusion. Uneven ripples. Lack of penetration. Recap.
In this topic, you have learned to select appropriate filler rod for tack welding and welding process. Prepare and set sheets for square butt joint in horizontal position. Tack weld. Inspect the weldments for defects.
Hello and welcome students. In this topic, you are going to learn about performing straight line beads and multi-layer practice on mild steel MS plate 10 mm thick in horizontal position using shielded metal arc welding SMAW process.
At the end of this exercise, you will be able to prepare the MS plate as per specifications: 150 mm length, 100 mm width and 10 mm thickness. Set the job in horizontal position. Deposit uniform straight line beads in horizontal position. Inspect the job for any surface defects. Now let us take a look at the equipment required to do straight line beads and multi-layer practice on a 10 mm thick MS plate in horizontal position using the SMAW process. Steel ruler, scriber, prick punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, electrode cable and earth cable, electrode holder, electrode, personal protective equipment, SMAW welding plant machine and their setup accessories, C-clamp. Let us have a look at the pre-welding preparations for straight line beads and multi-layer practice on a 10 mm thick MS plate in horizontal position using SMAW process. Use the 10 mm MS plate for this welding process. Mark the cutting measurement as 150 mm length and 100 mm width using a ruler and a scriber. Cut the MS plate along the measurement using a bench vise and hacksaw. Fix the MS plate in the bench vise. Perform the cutting as per the marking. File the edges of the MS plate. Check for the squareness of the MS plate. Clean the surface of the MS plate using a wire brush. Draw a straight line using a ruler and a scriber. Make the punching mark by using the punching tool along the line. Let us now look at how to do the welding process of straight line beads and multi-layer practice on a 10 mm thick MS plate in horizontal position using the SMAW process. Fix the punched job on a weld positioner in a horizontal position. Select a 3.15 mm electrode for performing straight line beading. Set the current to 110 amps in the SMAW machine. Start at the left-hand side of the plate and hold the electrode pointing upward at an angle of 70 to 80 degrees to the surface of the base metal. Use a travel angle of 70 to 80 degrees to weld. Making a bead on a plate weld in horizontal position is very much like making it in flat position. Reduce the current to get faster cooling. This helps to avoid overhanging the weld puddle on the bottom side of the plate. Use a faster travel speed and maintain a weld puddle size not larger than the coating diameter of the electrode. Weld using a short arc method to avoid sagging molten metal. Move the electrode to the right with a slight whipping motion. This helps to cool the puddle slightly, solidify faster and avoid sagging of the beads. Remove the slag with a chipping hammer and clean the bead with a wire brush. Inspect the weldment for any surface defects. Now we will look at the important points to be followed for a straight line bead and multi-layer practice on MS plate 10 mm thick in horizontal position using the SMAW process. Wear protective clothing. Ensure the correct current and electrodes are used. Inspect the belt bead for surface defects. Let us now see the defects. Undercut. Cracks. Improper bead profile. Excessive reinforcement. Crater. Spatters.
Recap. Let us do a quick recap of what you have learned from this topic. Prepare the MS plate as per size 150 mm length, 100 mm width and 10 mm thickness. Set the job in horizontal position. Deposit uniform straight line beads in horizontal position. Inspect the job for any surface defects. Thank you, students. Let us meet in the next session. Bye-bye.
Welcome, students. In this topic, we will learn about T-joint on 10 mm thick MS plates in horizontal position using SMAW process.
At the end of this topic, you will be able to select appropriate electrodes for tack welding and welding process. Prepare and set plates in T-joint in horizontal position. Tack weld. Weld T-joint in horizontal position using SMAW. Inspect the weldments for defects. Now, let us look at the tools required for T-joint on a 10 mm thick MS plate in horizontal position using SMAW process. Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, electrode cable and earth cable, electrode holder, electrode, personal protective equipment, SMAW welding plant machine, C-clamp. Now, let us see the pre-welding preparations for a T-joint on 10 mm thick MS plates in horizontal position using SMAW process. Cut two 10 mm thick MS plates, 150 mm length by 50 mm width. File the edges and inspect the plates. The bottom plate should be kept parallel to the ground and the other plate perpendicular. To avoid deformation of the metal due to contraction, preset the plates in such a way that the angle of the tack welded joint is slightly increased to 92 degrees to 93 degrees on the welding side. Place the joint in a horizontal position and tack weld. Keep the electrodes ready for each run. For root run, use 3.15 mm electrode and 120 amps current. For second and third run, use 4 mm electrode and 160 amps current. We have seen the pre-welding preparations. Let us look at the welding process of a T-joint on 10 mm thick MS plates in horizontal position using SMAW process. Deposit root run with 3.15 mm dia electrode and 110 amps welding current, maintaining the electrode angle of 70 degrees to 80 degrees to the line of weld and 40 degrees to 50 degrees between the vertical plate and electrode. Maintain a short arc to get uniform fusion and proper root penetration. Deslag and clean the root bead thoroughly. Use safety goggles while deslagging to protect the eyes from flying slag particles. Deposit second run with a 4 mm electrode and 160 amps welding current. The angle of electrode to the bottom plate has to be 55 degrees to 65 degrees and 25 degrees to 35 degrees to the vertical plate and 70 degrees to 80 degrees to the line of weld. The second run has to be deposited partly covering the root run and partly on the bottom plate. Give a steady movement to the electrode using a short arc. Deposit the root run in a straight manner. Avoid weaving movements. Deslag and clean the weld bead. Deposit the third and final run with a 4 mm dia electrode and 160 amps welding current. Angle of the electrode to the line of weld is 70 degrees to 80 degrees and 40 degrees to 50 degrees on both plates. The third run has to be deposited in such a way that the bead covers partly the root run and the second run and partly the vertical plate. There should not be a gap at the bottom toe line of the third run in order to maintain necessary throat thickness. If two-pass technique is adopted, the second run should be done in a weaving motion. Now, we will look at the important points to follow for a T-joint on a 10 mm thick MS plates in horizontal position using SMAW process. Use proper angle and travel speed of the electrode. Go along the leftward direction. Avoid over deposition and side undercut by using a proper angle and travel speed of the electrode. Inspect the fillet weld for equal leg length and correct size. Inspect to ensure the fillet weld is free from undercut and excessive lapping on the bottom plate. Let us look at the defects which can be identified during the inspection process. Over deposition, undercut, solid inclusion, porosity, blowholes, recap.
In this topic, you have learned to select the appropriate electrode, set the plates in T-joint, horizontal position and tack weld. Weld the T-joint with a short arc and uniform travel speed. Inspect the weldments for external defects.
Hello and welcome students. In this topic, you are going to learn about performing fusion run with filler rod in vertical position on 2 mm thick mild steel MS sheet using oxyacetylene welding process.
At the end of this topic, you will be able to prepare the MS sheet as per the size of 150 mm length, 100 mm width and 2 mm thickness. Fix the job in vertical position in the weld positioner. Deposit the bead in vertical position in an upward direction. Inspect the bead for any surface defects. Let us now look at the tools required for the OAW fabrication of fusion run with filler rod in vertical position on 2 mm thick MS sheet. Steel ruler, center punch, ball peen hammer, flat file, bench vise, tri-square, chipping hammer, steel wire brush, safety clothing, gloves, PPE kit, nozzle number 5, tongs, CCMS filler rod 1.6 mm, OAW setup, cylinder key, tip cleaner, spark lighter, gas welding goggles. Let us have a look at the pre-welding preparations for a fusion run with a filler rod in vertical position on a 2 mm thick MS sheet using the OAW technique. Follow necessary safety precautions. Cut the MS sheet as per the size 150 mm length, 100 mm width and 2 mm thickness. Keep the MS sheet on the table and scribe straight lines using a ruler. Do the punch mark over the straight lines. Clean the surface of the sheet from oil or rust. Clean the surface of the sheet from oil or rust. Fix the punched mark sheet on the weld positioner in vertical position at a convenient height. Select the number 5 size nozzle and fix it to the blowpipe. Select 1.6 mm dia CCMS rod. Set 0.15 kg per square centimeter pressure for oxygen and acetylene gases. Ignite the blowpipe and set a neutral flame. Deposit the weld in a vertical upward position. Let us now look at the welding method for fabricating fusion run with filler rod in vertical position on a 2 mm thick MS sheet using the OAW process. The weld bead is deposited from the bottom of the punched line upwards. Hold the blowpipe at 75 degrees and the filler rod at 30 to 40 degrees to the line of weld. The angle between the blow-up nozzle, filler rod and the sheet surfaces should be 90 degrees. Ensure the melting of the base metal and the filler rod is kept to a minimum as possible. Maintain proper angles for the blowpipe and filler rod. Move the blowpipe and filler rod without any side-to-side movements. Move along the marked line at a uniform speed in an upward direction. Do not allow the inner cone of the flame to come into contact with the molten metal to avoid a backfire. Completely deposit the weld bead up to the top end of the line and ensure to fill the crater. Ensure the undercut defects are avoided by proper manipulation of the blowpipe and the filler rod. Clean the bead and visually inspect for any surface or external defects. Now we will look at the important points to be followed for a fusion run with filler rod in vertical position on a 2 mm thick MS sheet by the OAW process. Wear protective clothing. Take due care that the weight of the blowpipe and hoses does not pull your hand downwards while the deposition of weld metal progresses upwards. Let us now see the defects. Undercut. Poor bead profile. Excessive reinforcement. Uneven bead profile.
Recap. Prepare the MS sheet as per size 150 mm length, 100 mm width and 2 mm thickness. Fix the job in vertical position in the weld positioner. Deposit bead in vertical position in upward direction. Inspect the bead for any surface defects. Thank you, students. Let us now meet in the next session. Bye-bye.
Good morning, everyone. In Chief Engineer Air Force Gandhinagar, from the Architect Division, a conscious effort has been made to improve the aesthetics of MAS buildings. Though the planning of the MAS buildings are very efficient, very good, because a lot of brainstorming goes into the planning aspects of this. However, the ultimate outcome